Physics works, or does it? Projectile is an object that moves through the air along a trajectory without a propulsion system. Energy is the ability that a physical system has to do work on other physical systems. Two forms of mechanical energy are kinetic and gravitational potential energy. The whole purpose of this lab is to launch a spring from a launcher into the metal bucket given the angle of the launcher and the distance between the launcher and the bucket.
Starring Ivy.
Kinematics is the study of motion. Motion has different branches such as velocity, acceleration, gravitation, momentum. Projectile motion is when an object moves through the air along the curved path. Velocity in the x direction remains constant. The only acceleration is the acceleration due to gravity acting downwards on the spring. X and y vectors are independent on each other. On releasing an object from a launcher, it reaches its maximum height and gains gravitational potential energy, which gets converted to kinetic energy on reaching the floor. Gravitational energy is when the object is at a certain height. Kinetic energy is as soon as the object is in motion. Elastic potential energy is stored in the spring that is stretched, compressed, bent, or twisted. Physics knowledge and skills used to launch the spring into the metal bucket from a certain distance and angle. Before the spring was launched on the big day, predictions were made. Certain equations were combined to derive the equation for K. Therefore, the constant K of the spring was predicted to be 15.3 newtons per meter. The value of K was used to calculate the x values with the given angles and distances. Equation for K was rearranged to derive the equation for x. X is equal to root mass multiplied by gravitational acceleration multiplied by distance divided by constant multiplied by sine 2 theta. Mass of the spring was 0.011 kg. Constant was calculated to be 15.3 newtons per meter. Using the x equation, the table was derived. The materials used are shown in the picture.
Wow!
The spring flinger was built keeping in mind various measurements such as the height of the metallic bucket, which was 37 cm high. 3 different ramps were made with angles 60 degree, 55 degree, and 50 degree to the horizontal. A paper clip was attached to the end of the spring so that it was easier to release. The spring was stretched to an x value and released so it hit the bucket. Constant for the spring was calculated to be 15.3 Newton per meter after various trials with the spring. Spring flinger was set as 0-meter marker tape in the school cafeteria. The cafeteria floor was marked from 3.5 meters to 8 meters. Angle dice was rolled to 40 degrees, which was 50 degrees to the horizontal for the spring flinger. 5-meter distance was pulled out. Spring was held against the ramp. Predicted x value 15.16 cm was stretched. It gained elastic potential energy. It was then released aiming for the bucket. The energy converted to gravitational potential energy and then kinetic energy. The spring did not enter the bucket in the first trial. It landed 0.1 meter to the right. That could have been due to sources of error such as constant of the spring change due to stretching the spring very often during practice, inefficient building, angles 30 degree, 35 degree, and 40 degree were not made to the horizontal, calculation errors, angle was big so the ramp was too steep, percent error was calculated to be 2%. The spring was stretched to 15.16 cm again, but this time it was made sure that the ramp was kept straight. The spring was released. This time, the spring entered the bucket. To improve the results, the spring used could have been stretchier. That could have resulted in a more precise distance traveled. Wood and other raw materials were used to build the spring flinger. They were weak and not very accurate. Too much practice loosened the nails and changed the angles. The ramps could have been slightly slanted, which resulted in missing the shot by 0.1 meter to the right. Spring was stretched back using a pencil. On releasing the spring, there would have been force of pencil exerted too. Metal could have been used for sturdier construction. Energy such as thermal energy due to friction and air friction was neglected while releasing the spring. The results could have been more accurate if the sources of error were eliminated. The results were valid. Overall, the purpose of the lab was to launch a spring from the launcher into the metal bucket given an angle and distance. This purpose was obtained in the second trial. Percent error for the first trial was 2%. This whole lab proved that physics knowledge and skills can be used to predict the landing distance of the spring. Therefore, physics worked, and it worked better than expected.